students, this is Jayalakshmi of Vaigi College of Engineering. Today we are going to discuss about that second unit, cellular architecture of this wireless communication. Let me go for the syllabus first. In this second unit we are going to discuss about that cellular architecture, that is initially we are going to discuss about that multiple access techniques, that is FDMA, TDMA, CDMA, that is frequency division multiple access, time division multiple access, code division multiple access, that is useful for utilizing the channels, utilizing the increasing the number of users. Then we are going to discuss about that capacity calculations, the cellular concept. In that architecture we are going to discuss about that frequency reuse, channel assignments, handling that handoff problem, interference and system capacity, increasing the system capacity, trunking and grade of services. Then we are going to discuss finally that the coverage and capacity improvement. Let us start with the first topic, that is multiple access techniques for wireless communication. In this one we are going to discuss about FDMA, TDMA, SDMA and CDMA. Why we are going for this multiple access? What is multiple access first? Multiple access is a technique whereby a variable number of users can access a common resource for the purpose of communication. See, the diagram itself shows you many users are going to use a common resource for transmitting that one. So when many users going to use a common resource, that time how the access can be allocated for the user, how these many users can utilize a common resource is explained in that multiple access. Let me start with that one. Many users are going to utilize a resource, a common resource at the same time. How we are going to share a finite amount of radio spectrum. When you are sharing that finite amount of radio spectrum, we have to concentrate on the performance and how they are going to transmit their data, how they are going to receive the data, and whether they are going to use a frequency domain or the time domain. Okay, any one of the domain can be chosen for transmission for multiple access. When you are going for this multiple access technique, we are having a frequency division multiple access, or time division multiple access system, then code division multiple access, then space division multiple access. They are grouped as narrowband system or wideband system. Let me start with that. Narrowband system or wideband system. Before going for that narrowband system, we will have that one frequency division duplexing. Duplexing means when we are going to transmit data, at the same time we are in need of receiving the data also. So two bands of frequencies for every user is needed for transmission purpose as well as for receiving purpose. So here we are in need of a duplexer circuit, that for transmission as well as reception we are going to use a separate band for transmission and reception. See that one. Here we are going to use a reverse channel with a different frequency, and then we are having a forward channel with different frequencies. Similarly, for time division duplexing, users going to use a forward and reverse link, and multiple users are going to share a single radio channel. Here we are using a forward time slot and reverse time slot for transmission and reception, but here no duplexes are required. Here it is explained with the diagram. For multiple access technique, if you are dividing the frequency among the multiple users, then we are calling that as a FDMA. If we are dividing the time between that channels, then we are calling that as a time division multiple access. When we are going for frequency and time with the code for each user, if the users are divided by codes, then it is called as code division multiple access. Let me start with that narrowband system. Here large number of narrowband channels are used, and usually they will go for the FDD or they will go for the time division duplexing. In that narrowband FDMA, we are having that one narrowband FDMA with FDD and FDMA with TDD, time division duplexing. Similarly, for narrowband time division multiple access, we are having TDMA FDD and TDMA TDD. So when you are going for this narrowband system, we are going for FDMA or TDMA. Here is the structure, how the logical separation of FDMA FDD is working. See here we have taken that frequency as well as time. Here each user is separated by user 1 and user 2. They are separated by this frequency. Okay, so each user is allotted with the frequency. User 1 is allotted with the frequency, user 2 is allotted with the frequency. They are having separate frequency for transmission as well as reception. So it is fully divided among the frequencies. So it is FDMA, FDD. Next we are going for that logical separation for FDMA TDD. See that one. Here we are going to divide each user with their frequency among the frequency. Each user is allotted with a frequency, but for transmission and reception they are not going for separate frequency, but they are going for that separate time slot for transmission and separate time slot for reception. So they are having FDMA TDMA technology. Okay, TDD duplexing. Next, logical separation for TDMA and FDD. Here each user is allotted with separate time period for their transmission. See that one, the time is separated here. Each user is allocated with different time slots, but they are going to use different frequency for the transmission uplink and transmission reception downlink. Okay, see here they are going to use separate time period is allocated. Here the time is allocated between the user 1 and user 2, but they are going to transmit the data, that is uplink is in separate frequency, downlink is in separate frequency. Okay, so this is how they are transmitting their data. Next, logical separation of TDMA with TDD. And in that previous one we have discussed about that we are dividing that each user has separate time duration for their usage, and here each user is having separate time. Time is divided among the users, and they are having separate time for transmission and separate time for reception. So they are going to use TDMA for resource allocation as well as for TDD for duplexing. Next we are going for that wideband system. When you are discussing about narrowband system, we are using only FDMA and TDMA. For wideband system, here large number of transmitters are going to use one channel. They are going to use TDMA technology or CDMA technology. When you are using TDMA with FDD or TDD, we are having TDMA FDD and TDMA TDD. When they are using CDMA technology, then we are having CDMA with the FDD and CDMA with the TDD. Based on the duplexing also we are having two separate branches. Here is the logical separation for CDMA FDD. Here each user is separated by their code, not with the frequency, not with the time. Here each user is separated with the different codes. Different codes is allocated for each user, and they are transmitting their data or receiving their data at different frequency. Okay, so the uplink and downlink are divided by the frequency separation. Here is the logical separation of CDMA with TDD. Each user is allocated with a code, and they are having separate time for transmission as well as separate time for reception. That is logical separation of CDMA in time division duplexing. Next, in the next thing we are going to discuss about that frequency division multiple access technique in depth, and we are going to discuss about time division multiple access technique, and then we are going to discuss about the code division multiple access. What is that FDMA? Already I told you, FDMA is a frequency division multiple access. Multiple users are going to use the frequency. Separate frequency is allocated for them. They are going to use their own frequency for transmission, and they can separate their transmission uplink and downlink frequency, or they can be separated by uplink and downlink time duration. Okay. Similarly, for time division multiple access, each user is allotted with different time slots, and in that time slot they are going to fully utilize that entire bandwidth, and they can be allocated for different time slots for transmission and reception, or different frequency slots for transmission and reception. And similarly for code division multiple access, they are going to separated by different codes, and they are going to utilize the entire bandwidth for the entire time with different codes. Okay, if they are using different timings for transmission and reception, then that is CDMA TDD, and if they are using different frequencies for transmission and reception, then they are in that CDMA FDD. We will discuss that in depth in the next video. Thank you.